F1 is not equal to Fp, it will not be a 3 dB point. So yeah, definitely you have to find the value of CE from the equation. So from this equation, once you know F1 value, RS, HIE, HFE will transistor. So you need to backtrace and find the value of CE. So this value of CE will determine the lower cutoff frequency F1. I told you, right, in the amplifier response graph, your graph will increase constant and then decrease. So you have a cutoff frequency here F1. So that F1 is decided by your coupling bypass capacitor CE. So very, very important that this capacitor CE will decide the uh, lower cutoff frequency. And usually we require this F1 to be as low as possible. And the CE, you can see the F1 depends on all these parameters, HIE, HFE, which are transistor dependent, and RS is your source resistance. So depending on what value of F1 you need, you can fix the value of CE. Or whatever value of CE you fix, you can correspondingly find what is the cutoff frequency F1. So both the things are possible. Okay, so the use of this capacitance CE will cause reduction in the low frequency response. So whenever you are going to use a bypass capacitance CE, definitely you will have the reduction in the lower cutoff frequency F1. Okay, so that is the observation here. If the biasing resistor are also taken into account, then the gain will be even more reduced. So that is what they are saying here. So it will lower the 3 dB frequency and also the gain, because you have the CE term present everywhere. Okay, and whenever you are going to include the effect of biasing resistors, even more the resistance value are going to impact the voltage gain, and it is going to be even more reduced in your common emitter amplifier. So this is the effect of CE on the low frequency response. Essentially, what we are finally concluding, whenever you are going to have a bypass capacitor parallel to RE, so this CE is going to affect which part of my voltage frequency response. It is going to affect two things. First one, it is going to affect the lower cutoff frequency, lower 3 dB cutoff frequency F1, and it is going to affect the voltage gain, mid-band voltage gain. Okay, that is going to be affected by the use of CE. But the first one, I need to have a lower 3 dB frequency. That is required for me, because only when the lower 3 dB cutoff frequency is satisfied, my band of operation will be improved. And reduction in gain, that is a loss for me. So you cannot gain both the things. Either you have to have reduction in gain or increase in bandwidth. Okay, both the things you cannot achieve simultaneously. So definitely when gain is going to reduce, the bandwidth is going to increase. So you have to compromise on bandwidth. Okay, so you cannot have a gain, high gain and high bandwidth amplifier. So when the gain is less, bandwidth is high. When the gain is large, bandwidth is going to be less. So they are inversely proportional. So any doubt on this topic, effect of capacitance on low frequency response? See, again, these may not so important part B question, but you should know if any problem occurs while you're doing lab exercises, whenever you're not getting proper response, you should know that which circuital component is going to affect that. So that level of debugging and all you can understand from these theory concepts. Any queries in this portion? Effect of common emitter coupling capacitor bypass capacitor on the low frequency response?